Example 1. You plan to buy a car when you graduate in 4 years. The car you want currently costs $20,000 and car prices are expected to increase by 5% per year. Part A asks, what will your car cost be by the time you graduate? Part B, if you wait another 2 years, then how much will the car cost? Okay. So here, we'll look at the solutions, but you're given the cost of the car right now. Okay, that's value of the car at time 0. We'll call it PV. And we know the N, right? The number of years is either 4 years or 6 years, depending on how long you wait to make the purchase. And we're given the rate at which the car price grows. Okay, the car prices are expected to increase by 5% per year. So that'll be our R. Okay. So you always want to start by drawing the timeline. And for this problem, it'll look something like this. So I'll have 4 years here, 6 years. We're given the car value right now, $20,000, and we know the rate at which the car price grows. It's 5% per year, and we're solving for two things: the value of the car in 4 years, and in part B, we solve for the value of the car in 6 years. Okay. Yeah, so we want to use the future value formula because that's what we're trying to solve for, given these other three components: the PV, the N, and the R. Okay, so we're going to choose to use this formula. Future value equals present value times 1 plus R to the nth power. And the future value of the car in year 4 is then 20,000 times 1 plus the R, 0.05. So 1.05 to the 4th power. Okay. And if you use your calculator, it's 24310.13. So if we were to mark the individual years like this value, 20,000, just grows by 5% in year 1, another 5% in year 2, another 5% in year 3, and another 5% in year 4. Okay, so it's just 20,000 times 1.05 in year 1, and then by year 2, it grows by another 5%, and so on. Okay, year 3 and year 4. This is just a formula that works the same way. Okay. Yeah. So future value in year 6 is the same thing. 20,000 times 1.05 to the 6th power. Now we have 6 years of compounding, and the answer for part B is 26,801.91. Okay, so we solve for this and this. Okay, so let's look at example 2. It's related. It says, if you can earn 3% per year by investing, how much would you have to invest today to make the purchase to purchase the car in example 1 in 4 years and in 6 years? Okay, so we just found the prices of the car in example 1. So let's go back to solution. So we're gonna use these values as the target values and try to determine how much you would have to invest today. Okay, So I'm gonna go down here. It's example 2. So here I'm gonna draw another timeline. First, indicate year 0 right now, and year 4 and year 6. So we know the car prices from the previous example. So $24,310.13. And in year 6, it'll be this. Okay. And here it says if you can earn 3% per year by investing. Okay. So now, if you go back to the problem, you can earn 3% per year by investing. So this timeline now represents the your investment. Okay. So up here, this timeline represented how the car price changes, but this timeline now shows you how your investment grows over time. Okay. So for this one, we have a different R. The rate at which your investment grows is 3%. Okay. So based on what we have here, we want to figure out how much you have to put in into your account to reach this amount and this amount. Okay. So the first part, I'll calculate the PV given the price of the car in 4 years. Okay. That is, I'll just use this formula, the present value formula, because again, we're given the other 3 components. The future value, when the future value occurs, what time is the cash flow in, year 4, and the rate. Okay. So PV is 24,310.13 over 1.03 raised to the 4th power. Okay. So this would be this value being discounted 4 years back to time 0. Okay, that's how the formula works. So this will give us 21,599.24. So this means if you put in this much into your account, in the account that generates 3% per year, after 4 years, the balance will grow to this value, and then you can purchase your car. Okay. So let's do the second part. If you were to wait 6 years, okay, 6 years, then we use the same formula, just with different numbers, right? Now it's raised to the 6th power. We're discounting it back to time 0, so we're going from time 6 back to time 0. Okay, that is 22,446.18. Okay, these are the answers.